1 minute.
Okay.
Once again, we will go back to this fluid flows. Classifications of fluid flows. There is a wide variety of fluid flow problems encountered in practice, and it is usually convenient to classify them on the basis of some common characteristics to make it feasible to study them in groups. First criteria: viscous versus inviscid regions of flow. When two fluid layers move relative to each other, a frictional force develops between them, and the slower layer tries to slow down the faster layer. As we discussing the viscosity, we had considered different layers are flowing over by over. Understand? So, for example, if a fluid film is classified into four layers, measuring the layer or numbering the layers from bottom to top. For number one, number two, number three, number four. So first layer is very nearer to the surface and contact with that surface. Second layer is overlap over the first layer. Third layer is lying over the second layer. Fourth layer is lying over the third layer, like that. In these three layers, each layer experiences the resistance by the adjacent two layers. So each layer tries to reduce the velocity of other layers. Understand? Okay, when fluid layers move relative to each other, a frictional force develops between them, and the slower layer tries to slow down the faster layer. This internal resistance to flow is quantified by the fluid property that is called as viscosity, which is a measure of internal stiffnesses. This viscosity also creates shear stress, and the shear stress is directly proportional to the shear strain. We discussed it in Newton law of viscosity. Viscosity is caused by cohesive forces between the molecules in liquids by molecular collisions in gases. Viscous versus inviscid regions of flow. There is no fluid with the zero viscosity, and and thus all fluid flows involve viscous effects to some degree. In last videos, we discussed the classified types of fluid: ideal fluid, real fluid, Newtonian fluid, non-Newtonian fluid, ideal plastic fluid. Now, what is meant by ideal fluid? A fluid which is viscousness and incompressible. But all the fluids in the universe is having viscosity. So there is a no ideal. That is why there is a no fluid with zero viscosity. And thus all the fluids involve viscous effects to some degrees. Flows in which the frictional effects are significant are called as viscous flows. Flows in which we may consider the frictional resistance, then that flow is called as a viscous flows. However, in the many flows of practical interest, there are regions, typically regions not close to the solid surface, where viscous forces are negligibly small compared to inertial or pressure forces. Neglecting the viscous terms in such a visit or invisit flow regions greatly simplifies the analysis without much loss in accuracy. So by this slide, what we can say, inviscid flows are the flows in which frictional resistance is negligible. In negligible. Okay, the fluid flows in which the viscous or the frictional resistance are negligible, then that is called as inviscid flows. See the next slide. Here, a liquid is flowing. That is called as a free stream. Understand? In this free stream, we place into two objects. These two are the objects. Once after placing the two objects in a free stream, the fluid takes two different flow patterns over this. Understand? See, this is the boundary layer. Boundary layer. The boundary layer is the layer which is formed by the fluid nearer to the boundary of the object, solid objects. Okay, nearer to the boundary of the solid surface. Understand? Away from this, the external to this boundary layer, the frictional resistance are negligible or not considerable. Within the boundary layer, where there is a viscosity. That is why this flow inside the boundary layer is having viscosity. That is why this is called as fully viscous flow. And away from the or external to this boundary layer, there is no friction at all. That is why there is no viscosity. Understand? Sorry, viscous forces are negligible. That is why this flow is called as invisible external flow. This is also invisible external flow. So here is it internal.
Yes.
Understand? This is the core. Between the layer between these two is the inviscid inertia internal flow, or we can take it as inviscid internal flow. Here also, the viscous flow effects are negligible. Understand? So the flow in which viscosity or frictional resistance is considered, that is called as viscous flow, and the flow in which viscous or resistance is considered negligible, that is called as invisible or invisid. And come for the next slide. Classification of fluid flow. A fluid flow is classified as being internal or external, depending on whether the fluid is forced to flow in a confined channel or over a surface. A flow of an unbounded fluid over a surface, such as a plate or a wire or a pipe, it is the external flow. Understand? Unbounded flow. Flow is flowing over certain objects. That is called as external flow. Understand? Whereas if the flow is flow in a pipe or a duct is called internal flow. Understand? Flow is flowing inside the objects. That is why we are calling them as a internal flow. Water flow in a pipe, for example, internal flow, and air flow over a ball or any exposed pipe during windy days. That is called as external. Simply, the terms is giving the definition for this. Okay, external flow, internal flow. The fluid flows inside the objects, or then that is called as internal flow. The fluids flows external the objects or over the objects. Then the flow is called as a external flow. And come for the next slide. Another classification of fluid flow: compressible flow and incompressible flow. A flow is classified as being compressible and incompressible depending upon the level of variation of density during the flow. Incompressibility is an approximation, and a flow is said to be incompressible if the density remains constant throughout the channel. Understand? The density is constant in a fluid flow, then that fluid flow is called as an incompressible fluid flow. Therefore, the value of every portion of fluid remains unchanged or remains constant over the course. The first question: when the flow is incompressible, okay, the densities of liquids are essentially constant, and the flow of liquids typically incompressible. Therefore, liquids are usually referred as incompressible substances. That is the thing. You cannot compress the liquid. That is why its density will be remains constant. How the density will remains constant? What is the expression for a density? Density is equal to mass by value. If value remains the same, then the density will also same. That is, all the liquid flows are considered as a incompressible fluid flow. Next, come for the next slide. A pressure. On the other hand, gas is highly compressible because when it is gas, we can compress it. Once we compress the gas, definitely its volume decreases. Volume decreases means density increases because density is equal to mass by volume. Understand? Okay, that is density is not constant. Density is not constant because such type of fluids are called as compressible fluids. Compressible fluids are fluids which density changes. Density changes. Okay, a gas flow can often be approximated as incompressible if density changes are under about 5%. Okay, if the density variation is less than 5%, the for gases also can consider incompressible. Density increases greater than 5%, greater than 5%, then we can call them as hello. చిరా ఇప్పుడు ఆన్లైన్ క్లాస్ జరుగుతుంది తర్వాత ఫోన్ చేయండి gases flow often considered are approximated as incompressible if the density changes are under about 5%. The compressibility effects of air can be neglected at speeds under about 100 meters per second. Compressibility effects of air can be neglected at the speeds under about 100 meters per second. Okay, if the air is blowing with a speed of 100 meters per second, we can neglect the compressibility effects. Okay, come for the next slide. What is this criteria? Compressible and incompressible. The till now, how many classifications we had? Four classifications, six classifications. What is this? Viscous flow and inviscid flow. Okay, internal flow and external flow, compressible flow and incompressible flow. And come for the next classification, laminar versus turbulent. Laminar versus turbulent. Here we are seeing your fluid patterns. This is slowly, smoothly flowing. Understand? Here is a vigorous flow. Okay, in the third figure or bottom figure, it is a vigorous, randomly. Now, okay, irregular fluid. But once we consider this middle figure, what we can say, slowly the fluid is changing its nature from laminar to turbulent or streamlined flow to irregular fluid flow. Okay, if the fluid is having a streamlined flow, then that is called as a laminar flow. If the fluid is flowing with random nature, irregularity, okay, then that is called as turbulent. If the fluid flow is changing its nature from a laminar to turbulent, then that flow is called as transitional fluid flow. Okay, see the definitions. Some flows are smooth and orderly, while other are chaotic. Okay, the highly ordered fluid motion is characterized by smooth layers of fluid flow. Understand? It's called laminar. Laminar flow is a flow in which has highly ordered fluid motion and smooth layers of fluid. Then that is called as a laminar flow. Understand? This is a ideally characterized fluid motion. Smooth layers of fluid is flowing. Okay. Now, the flow of high viscosity fluids such as oils at low velocities is typically laminar. Okay. The flow of high viscosity fluids such as oils at low viscosities is typically laminar. Highly disordered fluid motion. Highly disordered fluid motion that typically occurs at velocities, and it is characterized by velocity fluctuations. It's called a turbulent. Okay? Highly disordered fluid flow is called a turbulent flow. Highly లేదా smoothly fine orderly smooth flow is called a laminar. Okay, and come for another sign. Laminar and turbulent. The flow of low viscosity fluids such as air at high velocities is typically turbulent. Okay, the flow that alternates between being laminar and turbulent is called a translational. Okay, changing its nature from laminar to turbulent is transitional. Here, by without seeing the figures or sketches, we can how can we classify so and so fluid is laminar flow and so and so fluid is turbulent flow. Okay, by its properties, velocity, okay, understand, velocity, density, dynamic viscosity. There is a one dimensional less number. It's called Reynolds number. Reynolds number. It is having an expression rho u d by mu or rho u l by mu. Understand? The magnitudes for density, velocity, and the length of the pipe or length of the diameter and the dynamic viscosity uh, is in our hand. We can calculate its Reynolds number. And with this Reynolds number, we can say so and so fluid is laminar fluid flow and so is turbulent flow. For example, if a fluid is flowing through a pipe, then that Reynolds number 2300 is the critical number for turbulent flow. Okay, if the Reynolds number is less than 2300, that is called as a laminar flow. If Reynolds is in between 2300 and 4000, that is called as a transition. And if Reynolds number is greater than 4000, then that flow is called as a fully developed turbulent. By this, we can say so and so fluid is laminar. Okay, by seeing the figures or the sketches, if the fluid is having finely ordered regular flow, then it is called as a laminar. If the fluid is flowing irregularly, randomly, okay, vigorously, then that flow is called turbulent. If the fluid nature is changing from its laminar nature to turbulent, then that is called as a transitional fluid flow. Okay. Whereas, and for external flows, that is fluid is flowing over surfaces. For them also, we can classify, we can calculate the Reynolds number. Reynolds number is equal to rho u L by mu, where L is the length of the pipe surface or of the plates. Okay. For this, what is the critical Reynolds number means 5 into 10 to the power of 5. So by having the magnitude of density, velocity, length of the solid surfaces and viscosity, we calculate that and we get the value 5 into 10 to the power of 5. If the obtained value is less than 5 into 10 to the power of 5, then the fluid flow is called as a Reynolds, laminar flow. If the fluid flow is in between 5 into 10 to the power of 5 into 10 to the power of 7, that is called as a transitional flow. If the fluid, if the Reynolds number is greater than 10 to the power of 7, then the fluid is called as fully developed turbulent flow. So by this, we can say we have the information. Critical Reynolds numbers for pipes 2300 and a critical Reynolds number for plates 5 into 10 to the power of 5. Very important. Okay, next to come for the next classification. Natural, natural versus forced flow. Okay, the in other words, natural circulation flow or forced circulation flow, like that we can say. Natural. What is the what is meant by natural? A fluid flow is said to be natural or forced depending upon how the fluid motion is initiated. In forced flow, a fluid is forced to flow over the surface of the pipe by external force such as a pump or a fan. Understand? By using a pump, centrifugal pump or reciprocating pump, they are making the water or liquid to flow very fastly. Understand? Forcefully, they are making the fluid to flow. In such cases, that flow is called as a forced circulation flow. And natural flow means any fluid motion is due to natural means such as the buoyancy effects or gravitational effect. Okay, then that is called as 1 minute. Good morning, sir. Sir, civil engineer class జరుగుతుంది సార్. సార్ 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 సరే సార్ ఓకే సార్ రేపు సార్ రేపు సార్ ఓకే సార్ వస్తాను సార్ వస్తాను సరే సార్ ఏంటి సార్ ఏంటి సార్ వీడియోస్ సార్ సార్ వీడియోస్ ఇక్కడ రికార్డ్ కావట్లేదు సార్ ల్యాప్టాప్లో సార్ అదే సార్ అంటే మామూలుగా మనము చేసినప్పుడు మైక్రోసాఫ్ట్ అవి రికార్డ్ అవుతాయి అక్కడ విన్నాం సార్ అయితే మాకేం కనిపించలేదు సార్ తీసుకెళ్ళి చూపించాను అది సార్ సార్ రేపు వస్తాను రండి సార్ ఓకే సార్ సార్ సరే సరే మామూలుగా స్లైడ్స్ ప్రిపేర్ చేసిన స్లైడ్స్ అయితే ఉన్నాయి సార్ అవి అటెండెన్స్ టీమ్స్ వ్యూ అటెండెన్స్ మాత్రము డౌన్లోడ్ చేసి పెట్టుకున్నాను సార్ కాలేజీలో సిస్టమ్స్ ఉన్నప్పుడు మెయిల్లో పెట్టుకున్నాను సార్ అది సార్ సరే సార్ ఇక్కడ నాకైతే ఇక్కడ వీడియో ఏమి కనిపించట్లేదు సార్ మామూలుగా నేను ఇప్పుడు క్లాస్ చెప్తున్నప్పుడు మాత్రం ఇదంతా వీడియో వస్తుంది అవతల వాళ్ళు కూడా చూస్తున్నారు స్టూడెంట్స్ అంతా సరే సార్ రేపు వస్తాను రండి సార్ ఓకే సార్ నిన్న చేశారు సార్ నిన్న చేశారు సార్ నిన్న చేశారు అదే సార్ నిన్న చేశారు వీడియోస్ గురించి అడిగారు సార్ దీన్ని తీసుకెళ్ళి చూపించాను సార్ ల్యాప్టాప్లో డౌన్లోడ్స్ కనిపించట్లేదు అని ఎన్ని చూపించారు సార్ సార్ ఓకే సార్ హలో రైట్ if fluid flow is naturally initiated, that means by gravitational effects or buoyancy effects, fluid can also flow. If such fluid flow is happening based on that, then we can call them as a natural flow. Natural flow. Naturally, fluid if flows, then the fluid flow is called natural flows. By using any pump or a fan, if the flow is flowing, fluid is flowing, then that is called as a forced flow. Okay, this is the one more classification. Next classification, steady versus unsteady flow. Okay, steady flow and unsteady flow. The term steady and uniform are frequently in engineering, and thus it is important to have clear understanding of their meanings. The term steady implies no change at a point with the time. Okay, steady means no change in any value at a point. Understand? For example, if a fluid velocity is not changing or constant without any time change, then that flow is called as steady flow. Understand? That means, for example, irrespective of the time changes, if the fluid is flowing with a constant speed, then that is called as a steady flow. Okay, if there is any changes takes places with change in time, then that flow is called as unsteady flow. Next, the term uniform implies no change with the location or over a specified region or over a specified period, then that is called as a uniform. Okay, for example, sorry, in a simple manner, what we can say, if the fluid velocity is constant irrespective of the time, that is called as steady flow. If the fluid velocity changes with respect to the time, then that is called as a unsteady flow. Okay, and uniform means if a fluid velocity is uniform over a particular time period, then that is called as uniform flow. Okay, non-uniform flow means if a fluid velocity flows or changes over a certain period, then that is called as a non-uniform flow. Okay, non-uniform. These are the certain types of fluids. Before closing the class, once I can recall them, what are the types of fluid flow? First, viscous flow, inviscid flow, internal flow, external flow, compressible flow. Next, incompressible flow, and laminar flow, turbulent flow, transitional flow, and steady flow, unsteady flow, uniform flow, and non-uniform flow. Okay, these are the types of fluid flows. By this, I am closing the session. Okay, thank you. Tomorrow we will meet you. I will inform. Okay, you can leave now. Thank you.
Thank you.